Statistics is the broad term for the science of data. No matter what you're interested in, you will run into data in some form or some way. The food that you had for breakfast could be tallied up and include as statistics within a study about breakfast preferences. The exact time in the morning, well, hopefully the morning, that you had your breakfast could also be included as statistics within a study about digestion or meal preparation. Data is all around us, and statistics is how we organize and explain the mass amount of information in the world that we experience each day. So we have this wealth of information. Every bullet point or characteristic about your life or my life could be turned into statistics. That is a lot of information, and we would have no idea what to do with it if we didn't have a couple of rules to help us separate types of data and work with it in different ways. So to introduce you to statistics as a whole, let's start with one of those separations. The two main types of data that you need to know about are categorical and quantitative data, the difference of which can best be illustrated using data about this picture. So let's first collect some categorical data about this person right here. Well, from looking at him, the first thing you probably notice is he is quite tall. And number two, he is he's obviously a little challenged in the hair department. He's bald. And number three, he has quite a small head compared to the rest of his body. Now those three variables that we just collected are all categorical. Notice that all of these data are descriptive and most importantly, words. All of these points can eventually be used to categorize, you see what I'm getting at here? This person into different buckets or categories if we needed to. Most importantly, this type of data was collected specifically for the purpose of identifying or categorizing the person. If you took another person and they were also bald, well, now you have two bald people in your sample that you can analyze to see if there are similarities or differences. Next, let's collect some quantitative data about the photo and see what the difference is comparing it to categorical data. Gru is about 14.5 feet tall and can move at 200 meters per second. And for the sake of comparison, let's just say he's around 300 pounds heavy. Now, as you probably noticed, quantitative data is very true to its name. It is pretty much anything that is numerical and collected with the purpose of measuring or aggregating this data against other data points to achieve some sort of comparison. Now, please be careful when identifying whether a variable is categorical or quantitative purely based on if it is a number or words, as something like a phone number, social security number, or order ID number for a sale are all categorical variables and not quantitative, despite them being numbers. Think about what the purpose of collecting this variable was. Is it to categorize or uniquely identify the data point, or is it to measure or aggregate the data against something? You wouldn't add together phone numbers or social security numbers, you would use them to identify who the data point you're working with is. Okay, now that we know about these two types of data, that's cool. Why does it matter? Great question. Well, just like most things, statistics would be rather useless if it didn't seek to explain something. Just like how you're watching this video to hopefully learn something, we use statistics to tell each other things about the world. You should watch this movie because it earned a 94% on Rotten Tomatoes, which means that 94% of the audience that watched it liked it a lot, so you probably will too. Statistics' purpose is to ultimately tell us information and tell a story along the way. So how do we tell a story with a bunch of numbers and bullet points? And how do we tell it effectively using these two types of data that we've just learned about, categorical and quantitative, as guidelines for our story? Now, people like pretty things a lot, and naturally numbers and bullet points are not the most attractive thing to the majority of people, which is why my nickname in high school was Numbers and Bullet Points. Okay, I hate myself. Therefore, when we work with statistics, we gotta make them pretty. There are a few standard visualizations and graphs that you need to know about for any given statistics class, and those are as follows. But for the purposes of this video, and to illustrate the key difference between working with categorical and working with quantitative data, we're only going to look at these two, bar charts and histograms, but we will get to the other ones in a future video. Now, bar charts are a simple and intuitive way to look at categorical data. Let's say you want to compare the total number of people with different hair colors at your school. You could very easily ask each person at your school what their hair color is, tally up the totals under different categories, and make a bar chart displaying the tallies of each category, which would be the total number of people with black hair, and in the bar right next to it, the total number of people with brown hair, and so on and so forth. Histograms are exactly like bar charts, but there is one big difference that you need to remember, and that it is for quantitative data. You should never ever use a histogram to tally up categorical data. It is wrong. Now you might be saying, these two graphs look exactly the same. Well, you're right, but histograms group quantitative data into these buckets and display the distribution of the buckets along the graph. Suppose you have the ages of every person in your city and wanted to display the distribution of those ages. It would make sense to use a histogram in buckets of 10, which means people aged 0 to 9 would appear in one bucket, people aged 10 to 20 would appear in the next bucket, and so on and so on. Now, generally in statistics, bar charts are separated with a lot of gaps between the bars, so you can very clearly tell where one category starts and one category ends, whereas histograms have no gaps between the bars, so that you can clearly see where the distribution is heading and kind of what the shape of the data is. Oh, shape. We will get to that next lecture. And that in its core is the significance of knowing what type of data you're working with. Whether you're working with categorical or quantitative data, this will affect what types of graphs and visualizations you're going to use to tell your story, and fundamentally what type of question you're trying to answer. Just think of how hard it would be to conduct a meaningful analysis about how genetics impact how tall you grow if some of your data is in centimeters and some of it is in tall, medium, short word classifications. Not saying you can't, but it would make more sense to work with these two data types separately instead of trying to combine them into some weird Frankenstein's histo bar chart visualization thing. Yeah. As always, there will be additional resources to continue your learning in the description box below. And if you have any specific questions or comments relating to your course, please leave those in the comments below. I will try to answer all of them. Thank you, and see you next time.